a continuation of yesterday's lesson. It was just like a little 5-minute mini thing refresher added on to the end. If you don't need to restart your notes, you should just hop back in to where you stopped yesterday. All right, so
Wait, can you take another?
yep. So we're starting a new proof here. Given the 3 times the quantity 4 plus x equals 9, prove that x equals -1. We're going to work through this. Go ahead and have last night's homework out so I can swing by real quick and give you points for it.
I know, right? Why would you play the people that? Oh. Hearing.
We're gonna add something. Tomorrow.
Okay, everybody. Pretty good effort on the homework. I'd say across the board. All right. Your first statement is pretty straightforward, right? It's going to be 3 times 4 plus x equals 9. And the reason for that is given. Always got like the first one, usually given, makes like I
So, I don't like it. They're tedious.
Okay, so what could I write, lady? What could I write as my next statement? So what could I write as my next statement? Kelson, you hate these? So what can I write as my next statement?
I don't know.
Well, if you were just given that product, would you just self-correct? What would you do?
I would distribute
So you use the,
distributive property.
right, so you get 3 times 4 plus 3 times x equals 9. And as Kelson said, we use the distributive property. So one thing to remember about most of the properties, we're going to do it as we transition from this to the homework. I'm going to have you do it right now. The nice thing about most of the properties, at least the really important ones that we need you to know, is that they make sense. Did you just add 4 to both sides of your equation? Well, then it's the addition property of equality. Did you multiply by 3 on both sides? It's the multiplication property, or the multiplication property of equality. Did you distribute? It's the distributive property. All right, so they do at least make sense. Okay, our next thing that we're going to do, we're just going to combine these and get 12. We're going to combine these and get 3x, and it equals 9. And we're just calling that.
I think we watch this or everything on the answer.
Yeah.
I don't like that.
No, but you actually got the right answer.
Well, after.
And now you're calling yourself out and you're talking about even more.
Wait, I'm just saying, I'm asking a
You did
question.
something wrong?
Yeah, what? I flashed it again.
That would be super awkward. Like, for you to actually flash the camera, that would,
What's going on in your head?
All right. What could my next statement be? What would be the next thing So now we need to do. Sasha, what's the next thing I need to do? I'm trying to solve for x. Subtract what? What do you do? From? Thank you. So you get 12 minus 12 plus 3x equals 9 minus 12. So I subtracted from both sides of the equation. So the property I use, Katie, I subtracted from both sides of the equation.
Subtraction property of equality.
Subtraction property of equality. Subtraction property of equality. How long does it take to get to pass?
Probably got tardy book.
Yeah, I was just kidding.
That takes a while. Yeah, because there's a lot of people that get tardy book. There's like a line.
Hey, look at you, did your back. She's making 12 lessons at speed.
So annoying.
This is the letter.
I thought it was quick. I thought it was like, this is kind of quick.
She was. She would have been here before me because she turned around.
Alright. I take the easy statement. 12 minus 12 is 0. 12 minus 12.
Stop it. How did I know he was a How did I know?
I'm so annoyed.
Okay, 12 minus 12 equals 0. What property is that?
Simplified.
We simplified, but what's the super specific property?
I wrote it. Yeah, I think so. Yeah, so it's.
Well, no, the negative 9 minus 12, negative 3, I simplified. Inverse property of addition. Good.
What? How would it be inverse property of this? Inverse opposite? Oh. I just put on my left. Sorry, what's the difference?
This is just connected via Bluetooth. Yeah, so that helps. This is connected via Bluetooth. This is connected via USB cable. And I use a smartboard last year, so that's how I do it. Actually, this is nicer because it's like a board.
Would you?
Well,
Oh.
whoa.
I
Nandra, how about you not hate on camera? Oh, that's cool.
hate iron.
No, you said going well, so I feel like a long run. I was like, never returned it.
All right. Now, how can I go from 0 plus 3x equals negative 3 to 3x equals negative 3? Which property should I just use? Fred. Which one does it if I add 0 to anything, it stays the same?
Oh.
Stop that now. I'm just gonna hit the
So which one? If you add 0 to anything, it stays the same. What is that? It's going to be the identity property.
I feel like that would be uncomfortable like that. That's really crazy.
You're not judging me.
It just doesn't look comfortable.
All right. So we have the identity property of addition. That's how we can go from 0 plus 3x to just 3x. What do you say? Hey, Emily, what should this look like? So we get equals negative 3 divided by 3. This is the division property that works.
But I was right.
Don't be late. Can you wobble?
Who can't wobble?
What's
I can
wobbling?
I can.
What's wobbling?
You can?
Yeah.
What's wobbling?
Learn how to
We
walk.
did it in the.
All right.
Go back to that.
We get 1x equals -1. We just simplify to get that.
I think I found John.
Yeah.
Research.
Moment of truth.
Everyone can
Just shut up and
stare.
stare. It took a really long time. How far did it take us off? You found someone?
Yeah, she found me.
Oh. I heard you were like en route to class and you turned around. Originally, I heard you were homework here.
Yeah, I was like lost my earrings and then she stopped me. So I had to like walk all the way back and I didn't get on time.
How can I go from 1x equals -1 to x equals -1? What is the property that if I multiply anything by 1, it stays the same?
Oh, I don't know.
Can it? If I multiply anything by 1, it stays the same. Let me look at it. Identity property and
Are they all
I wish there was
wrong?
a cool way to remember these.
well, identity, anytime you see that identity thing in mathematics, what it does is it keeps it the same. So that's like that's what it means. So that's the easy way to remember the identity one. The properties of equality, well, did you add, subtract, multiply, divide to both sides? Okay. And there's an equal sign, so take remember that one. The inverse, or what? Another word for inverse. Opposite. Bless you. Yeah, so a synonym for inverse would be opposite. So how do you get rid of addition? You subtract. How do you get rid of multiplication? Well, you divide. So that's why I go there. And then the reflexive, symmetric, and transitive are the hardest.
Okay.
And those are the ones that we're going to go over.
Do you realize
This is overkill, so here's what we're going to do. Brandon, what's up? So here is what I need you to do. I have one note card for you for today. The purpose of this note card for today is I want you to write the 5-star vocab words. They are identity property of addition, identity property of multiplication, reflexive, symmetric, and transitive. Those are big properties, especially these last three, that we're going to learn a lot. So what you're going to be able to do is you're going to be able to use this when we're in class, when you're doing homework, so you don't have to scrounge through your notes every time you remember the reflexive topic. So I was going to give you this one. You're just going to write, you're just going to write like really small, it's like a little like note card, like a little reference guide.
So all the identity ones?
The 2 identity ones, and then the 3 right after that.
Every one that you said
All
was
in one.
like stars?
Like all you just write like a little note. So you would write like transitive property, colon, y equals x and x equals z or whatever it is that I wrote down. Yeah, okay. So there's a difference between the index cards that I gave you to write all your vocab words on, and this is just to you use the resource.
So can I use the card you gave us?
Yeah, but I just didn't want people to have to open up their note cards if they had it. That's fine. And there. All right, so let's say 3 minutes. What I'd like you to do, you should have your homework assignment out. I already checked it. What I want you to do is just go ahead and find those 5 key terms from yesterday.
I would like to read them.
Wasn't my fault. Hey, give me that look like this. This is good, boy. You're doing everything. Those 5 terms here. We plug that together. Yeah. This is your reference. I'm trying to help you guys qualify. The 5 you're doing are the identity property of addition, the identity property of multiplication, the reflexive property, the symmetric property, the transitive property.
Where's my pen?
Yeah, it's like on one note, we're going to end up writing a bunch of properties up. This is going to be you're going to write a lot of different properties on this as you learn more and more. It is have this one small, quick guide to look at.
I'm gonna take it. Let's see here, Victor.
What is tomorrow? Geometry tutoring tomorrow is during lunch. So it's Mr. Southie there. I haven't seen it. Okay.
Throw it away.
You want to throw it away? Yeah.
Oh,
There's
you're
always freaking old though.
Do you want to someone?
Okay.
Do you want to someone?
I
I gave you a, I printed it out.
I don't know. Okay. If you go this way, there's a couple of miscellaneous. I think so. Huh?
And Kelton, do you have all, I need all your homework. What are they?
I promise you, they're telling me that. That's okay, I'll give you that thing.
I got one where you're sitting now.
Okay.
Okay.
I thought we do that in there.
No.
People crazy.
You're really good.
Because she kept shaking her head.
No, I'm gonna send them.
Okay, everybody. Yeah.
Act like I have to do it. Never mind, look what you did. Okay.
All right. So let's take a look at last night's homework. What? The light? I don't know if it was on there.
Yeah.
So you're not really.
Oh, yeah.
Okay. So let's go ahead and let's take a look at last night's homework. All right. So the first 11 questions. Go ahead and stop. Follow along with the homework as you go. This is a really important homework assignment. So I'm going to ask you to show it to me again tomorrow. So please bring it tomorrow as well. Yeah.
Wait, do we have homework tonight?
Yep. So for everybody except for the like 3 of you who did it, you don't have anything that you said you wanted to. You who didn't do it have. Yep. Well, I have another homework for you as well.
You print it out or do we?
What? You don't have to print out. You can just do it. Like the old style where you look at the computer. Okay, number 1 is definitely G. And it's definitely the identity property. 0 plus 7 equals 7. That's the identity property of addition. Number 2 is the associative property of addition. The Ames test, it will ask you to identify the associative property. But I'm telling you right now, when you associate with people, you associate in what?
Group.
Groups. You got to have grouping symbols to be the associative property. Number 3, 9 equals 9, that's a reflexive property. Number 4 if x equals 4 and 4 equals y, then x equals y. That's exactly what the transitive property is saying. It says if x equals y and y equals z, then x equals z. Number 5, 3 times the quantity x plus 1 equals 3x plus 3. That is the distributive property. Number 6, 6 plus 3 equals 3 plus 6. That's the commutative property. Don't forget, when you take the AIMS, which is a couple months away, they're going to ask you about the commutative property. You're going to remember it. So Mr. Children's commute on a little scooter. A commute is there and back. It's the exact same distance, right? I commute to work and my commute is commutative property. It's the same backwards and forwards. Number 7 is the addition property of equality. That's what a bunch of people in last hour said. I wasn't 100% sure, so I had it circled. Actually, I had no answer for the 4th hour when we talked about it. We decided that it was going to be that because it looks like the addition property of equality. Because you have this adding 4 on both sides. I just don't think that's right. I'm still not 100% convinced that that's the correct answer. But
Wait, you don't even know?
well, looking at it, I really thought it was substitution. Because you have 3x plus 4 and 6 plus 4. Now they're trying to demonstrate that you can plug a 2 in for x, but normally you'd have to say that stuff. And then I was looking at all the other properties, and I knew it wasn't any of the other ones. And the only one that it kind of looks like is the addition property of equality. But if anybody has a better argument, I'd love to hear about what the answer is.
No?
I'll probably have to ask Mrs. Moraga and get a clarification on what she wanted for that one.
So you can
Kate, is your question?
us?
No, over.
I didn't do it, so
They don't get it out and follow along.
that's why I showed you this. Ow,
That had to hurt. Second one.
Yeah, so- cool.
What did room look like?
He's like, I know you want to go like this.
Put the passes out. Lights out. Number 8. If A equals B, then B equals A. That would be the symmetric property. Number 9. 3 times 1 divided by 3 equals 1. That'd be the... I just lost it. Sorry. It's the inverse property of multiplication. Wow, it was right there. If x equals 2, then 5x equals 5 times 2, which equals 10. That would be L, substitution. That would be substituted the 2 in. And number 11, I chose division property of equality by a little bit. That's 1 through 11. Hopefully if you didn't have all those correct. You want to... Good. For the first proof, the answer for number 12, that was given, right? That was the first number 12 that was given. Number 13, you distributed the 2 and the 5, the 2 to both the x and the 5, so it'd be the distributive property. You're subtracting 10 from both sides, that's the subtraction property of equality. And that's easy to remember, that you subtracted is equal.
We don't fix that. Sure.
There you go.
How else are we gonna fit in the box?
You can run past that, right?
It's bothering me.
There was a mistake on here, which I apologize for. It shouldn't have been 10, it should be 0, 0, and 0. Totally. All right.
What did you say? What did you say?
I told her it'd be okay. I told her it should be okay. Oh no, a human is interacting with another human
No, not like
in an undisclosed way. She looked like she needed a little pick-me-up. So I was trying to- You haven't spent like 13 weeks with me by now. You should be used to the type of outdoor behavior. Yeah.
How am I so confused? Yeah, she's never.
I know she's like,
You would
using it
you in the face.
too. She's like, she'll be like, I'm never coming back.
It's going so loud.
Okay, let's show me kind of discipline. Alright. So we have 2x plus 0 equals 0, not 10. Once again, sorry for the mistake. So 2x plus 0 equals 0. We got that through the inverse property of addition, right? Because 10 minus 10 is 0, and 10 minus 10 is 0. That's the inverse property of addition. Then we go from 2x plus 0 to just 2x using the identity property of addition. Don't forget, anytime you see the word identity, right, it stays the same. So we have an identity matrix, which is something we're not going to cover. But if you multiply the matrix by an identity matrix, you get the same thing.
No. What does 16 say?
16 says the identity property of addition.
Oh, man. I just really want to hear something.
You can go, you can log on, you can go to
I'm
EndNote.
ridiculous.
You just go to YouTube, you can search for Mr. Childers, and the videos pop up. Mr. Childers, yep.
30.
No, I believe that.
Snapchat.
I just hit upload. That would be so much work. You know, we don't do all that work. We divide by 2. This is Emily's favorite. It's a division property of equality. That's at least one that she knows. We then simplify. And then I think she wanted substitution.
What is that?
No, it's fine.
No, just hold on a second. I didn't even write it.
Hold on a second. Kelton's doing homework last night. He's counting down.
What did it?
No, I didn't say anything.
No!
That's my picture.
Nope.
No, maybe that's not.
Flip it again.
No,
You like telling me.
Oh, I used paper teams. Those are the answers to the first one. Okay, we gave you the statement after the reason. The reason should read as such. Given, distributive property, commutative property of addition, right? That's how we can shift.
Hold on. What was the other one?
Simplify. Number 24 should be subtraction property of equality.
Oh, it's going way too fast. Well, he's gonna finish before I can even.
In 25, we simplified.
Where's yours, baby? Where's yours?
26, we have the identity property of addition.
I like how when we get off track, you just help out. It scares me. It honestly does. Like,
That is-
what? What? This is what I mean.
Yeah, that's right. Yep.
Wait, look, 23.
You're advertising
Number 27 was the division property of equality, right? So we divided as an equal sign. Then we simplified, and then the last one was this. So remember, how we construct proofs is if we write a statement here, we have to give our reason over on the right.
What did you say? How you can what?
How we construct proofs, construct them, like how we
Oh,
build
I think
them.
that can stroke fruit. So I was like, what?
All right. What do you want?
I just can't read number 23 from here.
Simplify. Go ahead.
Not 23.
Alright, this is most likely what you're going to see on remember there's no big chapter test that has for this unit. There's the 2 projects, there's about 5 or 6 quizzes.
What's the other process?
Well, I'm not sure yet.
But
And
you have everything for the year planned out.
we had it until we decided to go to the geography.
So you only have like a quarter planned out? Well, it's a then geometry we would, but we're not. Math, whatever.
This is probably what you see on like the final, something like this, where there are reasons and statements given, you have to fill it in.
I thought geometry was like shapes, that's
That's third grade stuff. Statement, 2x plus 4 minus 5x equals 7. Then I can move the 2x and the 5x next to each other using the commutative property of addition. Then I can use substitution. 2x minus 5x is 3x plus 4 equals 7. And then subtract 4 from both sides and get the subtraction property of equality.
The number,
Yeah.
so the third row is negative 3x.
Plus 4.
Oh.
I then get negative 3x plus 0 equals 7 minus 4, which is the inverse property of addition. The reason I can go from negative 3x plus 4 to just negative 3x is using the identity property of addition. 7 minus 4 is just from simple space. The division property of equality, what else did I divide? Jane, can you fill in a negative sign right there? Right there. Right there. Right there. Nope. Nope. Right there. Yep. Negative sign right there. Or negative sign right there. So we want to divide by negative 3 on both sides. That's the division property of equality.
What is the?
Right here?
No, on the.
Right here? I'll get there. Ladies and gentlemen, please stop it. I think if x equals 3 divided by negative 3 through simplification. 39 says x equals negative 1. Substitution. And then negative 1 is up here for substitution. So I'm going to want to see this tomorrow. So please bring it. All right, you going to put your homework away?
No. Kelsey. Seriously, I told you no, man.
But
You can't just copy it.
I'm not going to copy it. I'm just going to get the ones that I didn't fill in right there when I was looking at you.
I'm just going to get the ones filled in that I didn't get a chance to copy already.
Can I not do it? Do you not want me to?
Can we put the second part away?
What? Yeah, we don't need that.
It's still on camera.
If you'd rather me not, then I'm going to.
Are you recording it?
Good student.
Oh my God.
You're welcome.
Thank you, Kelsey.
Woo! Like, you looked around like everything.
All right, ladies and gentlemen. Put any of your attention up here, please. Okay. Like I said, we're going to have a little mini unit, or a little mini lesson here at the end of class. I just need to refresh you on what parallel lines are, perpendicular lines are, and how you compare them. Given like two lines, so they're going to be parallel, perpendicular, intersecting. And so we're just going to chat about this real quick. Okay. What are parallel lines?
Lines that
I feel like there's
don't intersect.
Mine just never intersect in a single place.
Perpendicular.
That's what I want to hear.
What's up?
It's co-planar lines.
That's a word. Did you use that word, Kelsey?
Huh?
He said the same plane, which is the same thing as coplanar.
Planar really a word?
Coplanar, yeah, they're gonna
Because
be
you don't
coplanar.
have more vocabulary.
So well, you guys actually already took these, because it was on that geometry sheet, just to refresh you.
Oh, so we don't need to write down?
If you don't have these exact words, then write it down. Coplanar lines that do not intersect.
The word.
Alright, so here's what it means. If you, let's say you look at my little tablet here, this is a plane, and we can see these two lines running up the side, those white lines, those are parallel lines. And so no matter which way I orient my tablet, those lines are still parallel. Because they're coplanar, they're on the same plane, and they never intersect. So coplanar lines do not intersect. Does anyone know what the symbol we use for parallel lines looks like? Yeah, it's like two diagonal lines like that.
Why do you want diagonal?
So they can't be straight up and down?
Why not?
So, sure, because I said so.
Give me a real reason?
Not right now.
We have to have arrows.
Maybe like-
Not for that right there.
Maybe like,
Like something like diagonal. I think it's if they were this way. My guess is if they were horizontal, it looks like an equal sign. If they were vertical, it looks like two L's, or two uppercase I's. So sideways,
Nobody
they're
makes
right
their
there.
eyes like that.
I do. My eyes.
Regular uppercase, I have a straight line.
Yeah, what the heck?
Does anyone remember what are perpendicular lines?
Go clear lines that create a 90
Two intersect at a 90-degree angle.
Two lines that intersect and form a 90-degree angle. Anyone know what the symbol for perpendicular is?
like that?
Well, that would be a plus sign.
It's close to that.
Like, oh.
No, not quite.
Isn't it like this? Like this? It's like this.
Not quite.
Like,
Anybody
I'm
else?
gonna go with the bigger triangle.
That's what the right angle thing is.
But rotated, so it looks like this.
Oh, yeah.
Just like that.
Okay,
what I
but
said.
see.
What do you say?
What do you do air something?
He's the first
Okay.
Okay.
All right.
I think.
So, how do we determine if a line is parallel or perpendicular? All we have to do is just look at the slope. Right?
Aw, it's gonna make you complicated.
So, parallel lines have the same slope, but have different y-intercepts. So, for example, if I had y equals 2/3 x plus 5, an example of a parallel line to that would be y equals 2/3 x plus 4. Scroll up if you want to. Right, so parallel lines have the same slope, but they have different y-intercepts. Okay,
Okay, so if you record yourself writing this, then why do you record and write it?
because people said it's nice to see like that person and like their pace like going through. That's all. This was a. Alright, so parallel lines have the same slope but different y-intercepts. So if I told you the slope was 3/1, what would the parallel slope be? Victor? Nope. It'd be 3/1. It's the same. Right. The exact same. They're just going to have different y-intercepts. Now, what if I had the same slope and the same y-intercept?
You just say line.
It would just be a line. Does anyone remember the vocab word for what those lines are called? There's a C. Nope, but it has co in it.
Oh, coincided.
Coincided.
I
You
knew
didn't
it
know
had
that
co
word.
in it. I knew it had
Coincided.
I am.
Coincided lines, the two lines are on top of each other. They're the same line, they're coincided.
co. So it's just a circle.
Yeah.
So
Just
it's
you
a
know.
line.
I'm gonna remember that now, thanks to you. Coincided.
Coincided.
Because you said so. Coincided.
Oh,
I
yeah,
did not see
coincided, coincided, perfect. All right.
I didn't do that.
Okay, that might
I have a question.
No, sorry. Perpendicular lines have opposite and reciprocal slopes. So if I had a line, it was y equals 4/5 x.
Wait,
So if I had a line, it was y equals 4/5 x.
you don't need to write down, you start writing down what you say.
What is opposite and reciprocal of 4/5?
5, 4.
That would be reciprocal or the opposite. Negative 5/4, yeah. So a perpendicular line would be y equals negative 5/4.
We answered a question together. Jeez, I'm gonna say actually very upset.
You just give the reciprocal, so you take what's on top, put it on bottom, what's on bottom, put it on top. If it was positive, make it negative. If it was negative, make it positive. Yep. That's all you have to do. So for instance, if your slope equals -2, the perpendicular slope would be what? Yeah. Positive 1/4. Good. Opposite and reciprocal. Okay?
What do you have things for?
I was just thinking about where I was going. I was just thinking of the next thing where it's going.
Maybe in your face.
No one will say it.
I thought you were.
I mean, I have all my slides pretty done. Slides, guys. All right, we have, these are our last things for today. We have the parallel postulate, and we're also going to have the perpendicular. So the parallel postulate states, if there is a line and a point not on the line, then there is exactly one line with a point parallel to the other.
Oh.
So you can see here that I have this black line L, right? There's a line. This is that line right here, L. And a point not on that line, which is P in my little diagram. Then there is exactly one line through the point parallel to the given line. Right? So my line can't go up like this, can't go like this. There's only one line that can go through that point and be parallel. And we'll call it Does anyone remember the symbol we use to show that two lines are parallel? I don't know, you might not even know what that is. Fine. I don't know if you have time. Do you remember how you indicate that two lines are parallel? Like when you're doing your notation, do you remember that at all? Like when you learned about squares and rectangles and parallelograms, how you show that the opposite sides are parallel? And remember? Yeah, it's just put those little arrows up. So, okay, there's the symbol for parallel lines, which is the sideways line. But we're eventually going to get to the point where we're going to put notation like on like squares and rectangles and trapezoids, all kind of stuff. How we show symbolically that two lines are parallel is we put these little arrows like that on the two lines. That's stuff we're going to get into. I just needed to show that to you. Sasha and Tina? That's the letter R in cursive. I'm just calling that line R.
So it's just like.
Line R goes through point P and is parallel. Tina, what's your question? Yeah, right, it's line R and line L, and they're parallel.
Not right, so when it's
P is just that original point we used to draw the parallel line. All right, here's your last one. The perpendicular proximate. You can see it's in conditional statement form, it's really nice. If there is a point not on the line, so just like the last one, if there is a line and a point not on that line, then there is exactly one line through the point perpendicular to the given line. You remember we were told that to be perpendicular, it has to create a 90-degree angle. Or it has to create that 90-degree angle. So it's drawn to a bit for that first line. So we can see once again we have line L, we have point P, and what we're going to do is we're going to drop a line that is perpendicular. So when they were parallel lines, we indicated they were parallel by putting those little arrows on each of the lines to indicate that this is perpendicular. Anyone want to take a stab at what we're going to do? Anybody?
do a little thing.
Yeah, we're going to do a little thing. We're going to put a little square right there. Show that it's a right angle. That is how you show that those lines are perpendicular. And we can say that line R is perpendicular to line L. Time today, go ahead and pack it up. I'm not going to move away. No, it never happens.
Oh my
It's
god.
been happening like all day and all my house. It's so weird. It never happens.
You guys are doing very well with this stuff getting through content. You guys get through the most content every day.
Hey, you want to see something cool? Oh, Mr. Tree.
Does it need